Hello, everyone, and welcome back to Calculus. So today we are talking about limit laws. And these are going to be techniques that are going to make it easier to evaluate limits by hand. So instead of needing to go through carefully through our sequences or looking at graphs, we're going to be able to sort of algebraically compute our limits. So for the first example of a limit law is the sum law. This says that if I take the functions f of x and g of x and I add them together, I get a new function f of x plus g of x, right? And if I then look at that new function and take the limit as x approaches a, that's the same thing as, I'll get the same number as if I just took the limit as x approached a of f of x and then added on the limit as x approached a of g of x. So basically, this is just saying that that sequence breakdown, if I think about my x values approaching a, so I've got an x sequence, x1, x2, x3, and so forth, approaching a, then this function, f of x plus g of x, if I look at the sequence of y values that you would get there, you're going to get the same number as if you looked at the limit of just the f y values and then added on the limit of the g y values. So seeing this actually in an example, if we knew that the limit as x approached -1 of f of x is 5, and the limit as x approaches -1 of g of x is -3, then without knowing any more information about f of x and g of x, I can say that if I added those two functions together and then looked at the limit as x approaches -1, I would end up getting closer and closer to 5 plus -3, in other words, 2. Okay, so in order to sort of get us to more interesting examples, I'm going to go through the rest of the laws a little bit more quickly, and then we'll see examples that utilize those laws. So a couple more laws that we have are the difference and constant multiple law. The difference law is a lot like the sum law. It says that if I'm subtracting two functions, I want to look at the function f of x minus g of x, and then I take the limit as x approaches a. That's the same thing as taking the limit as x approaches a of f of x and subtracting off the limit as x approaches a of g of x. Similarly, constant multiple law says that if I take a function f of x and multiply it by some constant c, and then take limits, I could instead find the limit as x approaches a of f of x and multiply it by that constant c. We also have a few more laws. So product law says that if I have two functions being multiplied and I take the limit as x approaches a of that product, then I could break that into just the limit as x approaches a of f of x and multiply by the limit as x approaches a of g of x. Similarly, quotients can be broken up like this. So I could take the limit as x approaches a of f of x divided by g of x. And that's just the same thing as taking the limit as x approaches a of f of x, dividing out by the limit as x approaches a of g of x, as long as the denominator is not 0. Can also do power and root laws. So power law says that if I want to take the limit of my function raised to the nth power, then I could just find the limit of my function and then raise that to the nth power. As long as we're looking at positive integers n. And root law similarly says if I want to find the limit of the nth root of my function, then I could first find the limit of my function and then take the nth root. Again, another caveat being that here, if we're looking at even roots, then we know what is under here. So the limit as x approaches a of f of x, that would need to be greater than or equal to 0 for this to be defined and to work. Okay, so that's a lot of laws, but they're all pretty intuitive, basically just saying that limits interact well with things like multiplication, division, powers, and so forth. So let's go ahead and see an example of this in person. Okay, so what we're trying to do here is we are trying to find the limit as x goes to 2 of x squared plus 3x plus 7. And really right now, if I think about it, all that I have in our arsenal is I could come up with a sequence of x values that are getting closer and closer to 2, and then look at what the y values are doing in this function, but that feels messy. So instead, let's try to use our limit laws to break that down and do that a bit faster. So first thing that I'm going to notice is that in my function that I'm trying to find the limit of, I see a bunch of plus signs. And so I'm going to apply the sum law, which allows me to break up that limit into the limit of each of my individual pieces. So instead of having the limit of the full function x squared plus 3x plus 7, I'm now going to have the limit as x approaches 2 of x squared plus the limit as x approaches 2 of 3x plus the limit as x approaches 1 of 7. So I've already kind of made my life a little easier, and I'm looking at sort of easier functions on each limit. Okay, and then the next step that I'm going to do is I notice I'm probably going to want to do a power law here because I have a power. So I can think about x squared or do the limit and then square it. And then the other thing that I'm going to want to do is I'm going to want to use the constant multiple law because I have the limit as x goes to 2 of 3 times x, so I can pull that 3 out of the limit. Okay, and so that gets me to my next step. So instead of the limit as x approaches 2 of x squared, I'm going to think of that as the limit as x approaches 2 of x, and then square it. And instead of thinking about the limit as x approaches 2 of the function 3 times x, I'm going to bring the 3 out front and just think about limit as x approaches 2 of x. And then the other thing that I noted is you'll notice that I dropped my limit here. And that's because I'm thinking about the limit as x goes to 2, or let's should say 2, of 7. So as x goes to 2, my function is constant. It's always 7. So that limit should be 7 because that's what the y values are getting closer and closer to. In fact, they're just always 7. Okay. So then we're really close. So the next thing that I want to do is I want to figure out these, in each of these two things, I need to know what the limit as x approaches 2 of x is. That's really all that I have left. And if you think about that, as x approaches 2, if my function is y equals x, then my y values are also approaching 2. And so that is what lets me see that each of these values is 2. So again, that is on each of these. So as x approaches 2, our y value is also approaching 2. Okay. And so in total, what I get at the end of the day is going to be 17. I get 2 squared plus 3 times 2 plus 7. So without checking any sequences or anything like that, we have found that our limit should be 17. Okay, really important. Do not turn in work that looks just like this. You need to have these justifications that we just went through and talked about of why each of the laws and sort of what the logic is on how you get between each of your steps. So make sure that you're showing those justifications as you move along. All right, so next example, we want to find the limit as x approaches -1 of root x plus 3. Okay, so I'm going ahead, I'm doing this limit. First thing that I notice is I seem to have my function underneath a square root. And so first thing I'm going to do is I'm going to apply the root law. And I'm going to bring that square root out. So now I can think about just the limit as x approaches -1 of x plus 3. That's an easier function to think about. And then my limit is being applied to x plus 3. So that's a sum law, right? I have two functions being added together. And so I can break that limit into the limit as x approaches -1 of x, and add on the limit as x approaches -1 of 3. And if we think about each of those limits, we're now at that case where we can sort of logic through. Well, if x is approaching -1 and my y value is just x, or my function is just x, then my y value is approaching -1. And if my function is constantly 3, then as x approaches -1, my y values are just 3, so constantly approaching 3. And so that allows me to replace each of those limits by -1 and 3 respectively, getting that my overall limit should be √2. Okay. All right, so this is your chance to try it yourself. So you are being told that the limit as x approaches 5 of f of x is 9, and the limit as x approaches 5 of q of x is -1. So go ahead and try to use the not the root laws, the limit laws in order to find a numerical value for this full limit. So again, make sure that you're justifying each of your steps using the limit laws. This should take a good number of steps. So pause here and try this problem now. All right, hopefully you are back and you did actually pause and try this problem. So as a hint, the answer you should have gotten to is 2. So if you didn't quite get there, go ahead and chat with your instructor when you get to class. All right, thanks everyone.